Sampling distribution of sample variance. Sampling distribution of sample variance. Okay. Suppose if S square be the sample variance of a sample of size n drawn from a population with mean mu and standard deviation sigma, then E of S square equals to n minus 1 by n sigma square. Okay. This is the theorem, sampling distribution theorem for sample variance. If S square be the sample variance, so S square is sample variance and the sample size is n drawn from infinite population. This population is infinite population with mean mu and standard deviation sigma, then E of S square equals to n minus 1 by n sigma square. See, so the population size, consider population size infinite population. Okay, consider population size infinity. Consider population size infinity, and the sampling process is simple random sampling with replacement. SRSW1 is simple random sampling with replacement. Suppose we have infinite population, take one sample of size n from that population. Okay, if the population mean is mu, standard deviation is sigma, and S square is sample variance, then E of S square equals to n minus 1 by n sigma square. Suppose we have a population with infinite size, take one sample from that population, and the sampling process is simple random sampling with replacement. If the population mean is mu, standard deviation is sigma, and S square is sample variance, then E of S square equals to n minus 1 by n sigma square. What is n? N is sample size. We have, suppose this is one population. In that population, size is infinity, and take one sample of size n. A sampling process is simple random sampling with replacement. N is sample size. Then what is ES square? And S square is sample variance. E of S square equals to n minus 1 by n sigma square. N is sample size and sigma is population standard deviation. Okay, this is sampling distribution of sample variance. Now take one example. Suppose population is 134. Take one finite population 134. This is the population P 134. This is the population P, and sampling process simple random sampling with replacement. Sample size 2. Okay, sample size 2. Sampling process is simple random sampling with replacement from this population 134. This is the population. Sampling size is 2. So what are the samples? What are the samples? Samples are 11, 13, 14. Sample size 2 with replacement. That's why 11, 13, 14. Next 33, 34, 44, 43, 41. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 3, 3, 4, 4. 1, 3, 3, 1. 3, 1 is also here. 1, 3, 3, 1, 1, 4, 4, 1, 3, 3, 3, 4, 4, 3. Okay, these are the samples. Okay, so first calculate mu. What is mu? Mu is population mean. So population mean mu equals to 1 plus 3 plus 4 divided by 3. Population mean mu, that is 1 plus 3. It is 4 plus 4. It is 8 by 3. So population mean mu equals to 8 by 3. Now calculate population standard deviation. So first calculate population variance. So population variance sigma square. Population standard deviation is sigma. Population variance sigma square equals to 1 square plus 3 square plus 4 square divided by 3 minus mean 8 by 3 whole square. Okay. So 1 square plus 3 square plus 4 square divided by 3 minus 8 by 3 whole square. This is 1 square plus 3 square plus 4 square divided by 3 minus 8 by 3. It is 14 by 9. Just simplify, you will get it is 14 by 9. Okay. Now, sampling distribution of variance. Sampling distribution of sample variance. Sample variance. Sampling distribution of sample variance. So, what are the samples? Samples are 1 1 1 1 1 3 variance of each sample. So what are the samples? Variance of each sample. Samples are 1 1 1 3 1 4 3 1 3 3 3 4 4 1 4 3 4 4. These are the samples. 1 2 3 4 5 6 7 8 9. These are the samples. And calculate variance of each sample. Variance of each sample. So 1 1. There is no variance. 1 1. There is no variance. So it is 0. Now calculate variance of this sample 1 3. Variance of this sample 1 3. It is 1 square plus 3 square divided by 2 minus 1 plus 3 divided by 2 whole square. Okay. Variance of this sample, it is 0. There is no variance. But for this sample 1 3, variance is 1 square plus 3 square by 2 minus 1 plus 3 by 2. It is just calculate. It is 1 plus 9 10. 10 divided by 5 2. It is 5 minus 4. It is 1. So 1 3 variance is 1. Here also we have 1 3 1 variance 1. Now for this sample 1 4, variance is 1 square plus 4 square divided by 2 minus 1 plus 4 divided by 2 whole square. It is 1 plus 16, 17 by 2, 17 by 2 minus 5 by 2, that is 25 by 4. It is 9 by 4. Okay, 9 by 4. So 9 by 4 and 4 1 also 9 by 4. 3 3 0 4 4 0. Now for 3 4 variance is 3 square plus 4 square divided by 2 minus 3 plus 4 by 2 whole square. So it is 16 plus 9 25 by 2 minus it is 7 49 by 4. 49 by 4. It is 1 by 4. So 1 by 4 1 by 4. Okay. So these are the samples and corresponding variance. Now we create the table, sampling distribution table for sample variance. Sampling distribution table for sample variance. Okay. Sampling distribution of sample variance. Sampling distribution of sample variance. So write sample variance. Here probability mass. Probability mass. So what are the sample variance? Sample variance are 0, 1 and 9 by 4. Sorry, 0, 1, 1 by 4, 9 by 4. Sample variance are 0, 1, 1 by 4, 9 by 4. Okay. Sample variance are 0, 1, 9 by 4, 1 by 4. These are the sample variance and corresponding probability mass. So we have total sample variance 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Out of 9, 0 corresponding frequency 1, 2, 3. So 3 by 9, 3 by 9. Now 1. We have one frequency of 1 is 1, 1, 1, 1, only 2. So it is 2 by 9. 1 by 4, we have 1 by 4 2 times. So it is 2 by 9. 9 by 4, we have 2 times. It is 2 by 9. So this is the sampling distribution of sample variance. Sampling distribution of sample variance. So we have sample variance 0, 1, 1 by 5, 1 by 4, 9 by 4, right? Sample variance 0, 1, 1 by 4, 9 by 4. Number of total number of variance, sample variance is 9, and frequency of 0 is 1, 2, 3, 3 by 9. So corresponding probability mass for sample variance 0 is 3 by 9. For 1, frequency 1, 2, 2 by 9. 1 by 4 2 times, 2 by 9, 9 by 4 also 2 times, so it is 2 by 9. This is the sample variance, sampling distribution of sample variance. Now calculate E of S square. E of S square. E of S square. E of S square equals to 0 into 3 by 9, 0 into 3 by 9 plus 1 into 2 by 9 plus 1 by 4 into 2 by 9 plus 9 by 4 into 2 by 9. Okay. Spectrum points into corresponding probability mass. 0 into 3 by 9 plus 1 into 2 by 9 plus 1 by 4 into 2 by 9 plus 9 by 4 into 2 by 9. Okay. You will get it is 7 by 9. It is 7 by 9. You will get 7 by 9. Okay. So E of S square, that is expected value of S square. It is 0 into 3 by 9 plus 1 into 2 by 9, 1 by 4 into 2 by 9, 9 by 4 into 2 by 9. You will get 7 by 9. Okay. N minus 1 by n sigma square. N minus 1 by n sigma square. N is sample size. Sample size is 2. Minus 1 by 2 into sigma square. Sigma square, I think it is 14 by 9. 14 by 9. Okay. 14 by 9. So it is 7 by 9. So n minus 1 by sigma square, it is 7 by 9. N minus 1 by sigma square, it is 7 by 9. E of S square also 7 by 9. So E of S square equals to n minus 1 by n sigma square. E of S square equals to n minus 1 by n sigma square. N minus 1 by n sigma square, it is 7 by 9. Sigma square is 14 by 9. Sigma square is 14 by 9 and n minus 1 by n, it is into sigma square, it is 7 by 9, and E of S square is 7 by 9. So these are equal. So E of S square equals to n minus 1 by n sigma square. Okay. So sampling distribution of sample variance. From sampling distribution of sample variance, you can calculate E of S square, that is n minus 1 by n sigma square. Okay. Suppose if small s square equals to n by n minus 1 capital S square. Capital S square is sample variance. Capital S square is, this is sample variance. This is sample variance. N is sample size. If small s square equals to n by n minus 1 s square, then E of small s square equals to sigma square. Sigma square. Okay. S, what is capital S? Capital S square, this is sample variance. N is sample size. Then if small s square equals to n by n minus 1 capital S square, then E of small s square equals to sigma square. What is sigma square? Sigma square is population variance. Sigma square is population variance. Okay. See, E of small s square equals to E of, now small s square is n by n minus 1 capital S square. N is constant, so it is n by n minus 1 E of S square. E of S square. So it is n by n minus 1. Now E of S square, that is n minus 1 by n sigma square from sampling distribution of sample variance. E of capital S square, it is n minus 1 by n sigma square. This is from the theorem of sampling distribution of sample variance. So n minus 1 by n sigma square. So it is sigma square. So E of small s square is sample population variance. S square is sample variance. N is sample size. If small s square equals to n by n minus 1 capital S square, then E of small s square is population variance. Okay.